class. Today we are going to continue lecturing on compounds. Last time we learned about classifying compounds between ionic and covalent, and we're going to continue our discussion by actually looking how to name compounds. The reason we're going to learn about naming compounds simply because it's an easier way to do chemistry, since moving forward we're going to talk about how different chemicals react and so on and so forth, and we're going to represent these in formulas and equations. And if I were to give you the names, you should be able to come up with the formula in order to do those reactions. And there is a systematic way of naming compounds, and we're going to go through. First, we are going to learn about some of the common names. So step one would be to recognize which one are those common names. So all right, that'd be water, ammonia, CH4 is methane. Actually, NaCl, we are not going to call it table salt, but rather we're going to call this sodium chloride. So I wouldn't worry about that it's actually a common name. We're not going to worry about it. All right. Next, we are going to determine what class of compound is it. Is it ionic or is it molecular? We have a certain set of rules that we're going to follow for ionic compounds that are different than molecular compounds. So we need to determine which one it is. In addition, within ionic compounds, there are also different set of rules that we are going to follow. And we are going to, first, let's remind ourselves what ionic compounds are. Okay, so for ionic compounds, we got ourselves a metal and a non-metal. Okay, for example, sodium chloride, that is a metal, and this is a non-metal. So we got ourselves a metal and a non-metal. The metal is always in the beginning. We can have it a binary compound like sodium chloride, or we can have an ionic compound that contain a polyatomic ion, such as sodium nitrate. All right, an ionic compound such as sodium nitrate. Then we have molecular compounds. With molecular compounds, we can have two nonmetals. For example, we got carbon monoxide or carbon dioxide, where you have two or more nonmetals. Carbon is a nonmetal and oxygen is a nonmetal. So we got ourselves nonmetal with nonmetal, therefore we have a molecular compound. We are going to stick to only binary covalent compound. In other words, only two nonmetals. All right, only two nonmetals. Then within molecular compounds, we are going to discuss acids. And those acids are also molecular compounds, but they're compounds that start with an H. All right, and we have two types of acids. Those acids could be binary or oxyacids, and we will actually look at both of those separately. We're going to explore binary acids, then we'll go on and look at oxyacids. All right, within each, we are going to look at the subclass of the compound within it. right? We already mentioned that, binary ionic, or is it ionic with a polyatomic ion? Is it a binary molecular, or is it an acid? Or okay, and within acids, is it binary acid or is it an oxyacid? All right, so let's take a look at ionic compounds first. We already said that we got a metal and a non-metal with these ionic compounds. So if we were to look at the binary ionic acid without polyatomic ions now, we are going to divide our compounds into two classes, type 1 and type 2. And this type, it has to do with the charge on the cation. It has to do with the charge on the cation, and we're going to talk about this a little bit more when we move forward. Then also, whether it's type 1 or type 2, it does not have to contain a monoionic anion. It could be a polyatomic ion as well, and that's okay. So we can apply the same rule whether we have something like chloride, a monoatomic ion, or if we have a chlorate, polyatomic ion. Whichever one, we would still apply the same rule. All right. Then when we go down, we'll look at, for molecular compounds, we only going to look at binary molecular compounds. So we're not going to worry about any of this stuff. It'll be right off the bat, one type of compounds. We'll look at them, we'll name them. Then when it comes to acids, we're going to look at whether it's a binary acid or it is an oxyacid. For ionic compounds, we're going to name the cation if it's followed by the name of the anion. For the cation, if it's type 1, we simply going to use the name of the metal. We're not going to add anything else. The metal name, if it's type 1. If it's type 2, we're going to also use the metal name. We're going to indicate the charge if it's type 2. Since it's all dependent on charge, we will indicate the charge. Sometimes we can have cation that it's polyatomic ion, and we'll do that. For anions, we can also have it as a polyatomic ion. So those polyatomic ions could be anions or cations. And we just name them as is. We will learn how to name polyatomic ions. So we will have those names as is. When it comes to monoatomic ions, as we learned last week in our discussion, the naming, we keep the stem of the name, we're going to change the ending to IDE. Those are some of the monoatomic ions that we learned about last week. Just a quick reminder. Notice how we keep the stem of the name. For example, fluorine, we're going to get rid of the INE and we're going to change it to fluoride. Chlorine, chloride. This becomes bromide, iodide, oxide, sulfide, then we have nitride. That's what we're going to do with the monoatomic ion. Now let's take a look at naming our ionic compounds. First, let's define which ones are type 1, then we'll go on and talk which ones are type 2. So first, let's focus on type 1. We'll come back and talk about type 2. For type 1, step 1, as soon as you recognize that you have a metal in your compound, you need to determine whether that metal cation has only one charge or would it have multiple charges. So type 2, multiple charges, type 1, single charge. So let's do that. For type 1, that would be single charge. And for type 2, that would be multiple charges. The ones that have only one possible charge, a single charge, that's going to be group 1A on the periodic table. Group 1A, those are the sodium, lithium, and the rest of the elements within that group. Then we have group 2A, and that would be a group where you have calcium, magnesium, and the rest of the elements in that group. Then we have group 3. We're going to look at aluminum. It has 3+ charge. Okay, aluminum will have 3+ charge. Then we got ourselves cadmium, 2+, zinc, 2+, and silver just +1. And silver +1. Those are the type 1 elements. So if you were to look on the periodic table, it will be group 1, group 2 on the periodic table, then you have the aluminum group right here in the main group element. Then we have within the transition metals, we have these three right there: cadmium, zinc, and silver. Those are type 1. The rest of the metals are going to be type 2 metal cations. All right, and those we'll talk about them, the rest of them. So let's see which ones are that have a single charge. Again, as I told you on the previous slide, we got ourselves the elements of group 1A. They have one charge, there we go, +1. Then we have the element from group 2A, they have 2, +2. Then we got aluminum, we got zinc, we got silver, as well as cadmium, 2+. Now the rest of the elements, and the common ones are right here. There are some more to this, but those are the common ones that we're going to learn about, and that would be, notice how chromium has 2+ and 3+, iron 2+, 3+, and so on and so forth. Notice they have multiple charges that they come in. And the way we indicate those, the way we name them, the name is always followed by parentheses and Roman numeral to indicate the charge. So let's take a look at chromium here. Chromium exists in two charge states, either chromium 2 or chromium 3. And notice for chromium 2, we just call it chromium 2 with that charge right there, Roman numeral 2 in parentheses. Chromium 3, on the other hand, it has this Roman numeral 3 in parentheses. That is true for the rest of the element. The charge is indicated in Roman numeral in parentheses like we did here for chromium. We also have to learn the older names, the convention. There's a list of the names right here on the right side of the table that tells you the older names for these metals. Just a quick note here for the older names. Usually the lower the charge, then the ending is OUS, and the higher the charge, the ending is IC. So for chromium 2, it'll be called chromus. For chromium 3, we call it chromic. All right, same thing. Look, for iron 2, it's ferrous. For iron 3, it's ferric. You should memorize that table. All right, let's take a look at some of this. If we look at lithium, it is type 1, since it's from group 1A. We'll look at copper. Copper is a transition metal. It's not on any of our list. It's one of those other elements, therefore it is type 2. We'll look at gallium. Gallium is also type 2. Tin, same thing, type 2. It's not one of the main group elements. Strontium is a main group element. Gallium, your textbook says it's type 1, but it's not. It comes with a variable charge. So you can, actually, let's ignore that one right here. comes as a variable charge. The way we name these is by going through the name of the cation, listed first. The name of the cation, we list it first, followed by the name of the anion. And keep in mind, the name of the anion always ends with IDE. Always ends with IDE. Okay, for example, let's take a look at CSF. If we're to look at CSF, first we determine cesium is a type 1 cation. Okay, so that will be type 1 cation. We don't have a polyatomic ion, we have a monoatomic ion for this. So that would be, this will be fluoride. And this is, CS is type 1, so we simply just name it as cesium fluoride. All right, cesium fluoride. CSF is not one of the exceptions, so we don't have to worry about it. We just go simply to cesium fluoride. All right, let's go through here. Potassium is also type 1. Potassium followed by Cl, so that makes it potassium chloride. This is magnesium bromide, and that one is aluminum sulfide. With type 2, we also gonna do the same thing as we did with type 1 with one exception. So we're gonna start by naming the name of the metal cation, but we're not gonna jump directly to the name of the anion. We need to indicate in parentheses the charge of the cation. We have to indicate what the charge is. We have to indicate what the charge is. We can either do that, do both, name of the cation followed by the charge. We get that from the Roman numeral in parentheses. Or alternatively, we could use the older name. Either one of the two works, and followed by the name of the anion. Okay, just a quick reminder again, that's the table. You need to know the older names, familiarize yourself with the older names, and take a look how those charges vary. One thing is going to be, how can we tell what the charge is going to be? So let's go through and take a look at the following example. I have OU2S3 in this example. We need to, right off the bat, this is a ionic compound. If it's an ionic compound, we're gonna name it by determining the type of the cation first. This is gold, and it's type 2 because gold is not part of any of the main group elements, therefore it will have a variable charge. Before we can name it, we need to determine what that charge is, and that's the trick here. We are going to use the monoatomic anion, in this case the sulfide ion, to determine what is the charge going to be. Okay, so we need to determine the charge, and we're going to use the sulfur anion in this case. That's how we're going to determine the charge. So let me walk you through this. We know that sulfur is from the oxygen group, right? Group 6A from the periodic table. That means it's going to have a charge of 2 negative. How many sulfurs do we have from this formula? We got 3 sulfurs. So I'm going to take 3 and I'm going to multiply that by 2 negative. That's going to give me 6 negative. All right, that's going to give me 6 negative. Okay, that's what I'm going to get right there. This must equal the charge on the cation. That means the charge on the cation, the total charge, must be plus 6. Since on the anion it's negative 6, the total charge on the cation must be plus 6. But I have 2 of the cation. That means that plus 6 must be divided by 2. Since I have 2 of them, I need to divide that plus 6 by 2, and that's going to give me a 3 plus charge. I hope this is clear. So it will give me 3 plus charge. So now I know the charge on gold is 3 plus. So when we name this one, we're going to name it as, let me get this back in here. So we're going to name this, this is not working properly. So bear with me, guys. Bear with me. Gold 3. I don't know why this is not writing correctly here. Gold 3 sulfide. Let me try again right here. Gold 3 sulfide. Okay, the S is not coming up. You got the point, guys. So that's gold 3 sulfide. Let's come up with the formula for manganese 4 sulfide. Now we're given the formula, and we're going to go from the formula to the name of the compound. So this is going to be the other way around. We're not being asked to name the compound, but rather to come up with the formula from the name. Okay, so let's go through it. We got here manganese 4 sulfide. So I know that manganese 4 is Mn 4 plus. Let me correct that. So it's 4 plus. Then we have sulfide 2 minus. So when we put them together, we're going to cross the 2. And we end up with Mn2S4. We did that last week in class. And I told you, if you recall, guys, that we need to always write ionic formulas in the lowest possible ratio. So I'm going to divide this by 2, and the formula will be MnS2. We're going to check the charges. Mn is plus 4, and sulfur, I have 2 of them, and each is negative 2. That's negative 4. That formula works. Okay, so let's look at a practice. Usually in class you'll be doing this, but bear with us. We're gonna, hopefully we'll get back to class within a couple of weeks, but for now let's continue with this. If I have copper 2 ion with a nitride ion, how would I write that formula? So I go with copper 2 ion and a nitride ion. It's 2 plus on the copper, 3 minus on the nitride. You notice I'll take the 3 from the nitride and make it a subscript for copper, and I take the superscript from copper and make it the subscript for the nitrogen. So you end up with Cu3N2. The ferric ion with the bromide ion. Bromide has negative 1, ferric 3 plus, so I'm going to need 3 bromides for 1 ferric ion. Okay, let's name the following compound. It's not one of the exceptions, right? So we need to go through and determine what it is. It is an ionic compound, and copper is type 2, not type 1. Okay, so it's an ionic. It's a binary compound, and it is type 2. The cation is copper, and it's type 2. That means I need to use the charge on chloride in order to determine the charge on copper. And the charge on the chloride ion here is negative 1. I have only 1 of them, and I have only 1 copper. Therefore, the charge on the copper ion is plus 1. That would allow me to balance the charge. Now I know that it's copper 1 ion. It has +1, so it's copper 1 ion. And I have the anion as a chloride, so the name will be copper 1 chloride. That's the name, copper 1 chloride. Let's go through and see if we can name several here. All right, so let me walk you through this stuff. Oops, where'd it go? Oh, here it is. Let me walk you through. So let's take a look at, this is an ionic compound. And Ti is one of those elements that is not type 1 cation, so it's type 2. That means I need to determine the charge on the anion. My anion is the chloride right here. It has -1 and I have 4 of them. That means the total is -4. The charge on the cation, the total charge on the cation should be +4, and I have only 1. That means the charge on it is +4. So when I name it, it's titanium 4 chloride. Let's look at the next element. This is lead, and that's bromide right there. With lead, it's also type 2. Bromide has -1 charge. That means the total is -2. I only have 1 lead, then the charge must be +2 on the lead. Must be +2, so we're going to call it lead 2 bromide. Now let's look at this iron element right here. Sulfur is -2, and I have 3 of them. That's going to give me -6 total. It's going to give me -6. I got 2 iron right there. So the total is going to be +6 for iron. I have 2 of them. That means the +6 divided by 2 is going to give me 3+. So it's iron 3 sulfide.